So today's a very exciting day. We've all been waiting a long time for today. We are visiting the campus of Griffith Uni here at Nathan, and we visited it so we can inspect the lab facilities here that have been used as part of our anaerobic co-digestion project. So it's a project which has been funded by our industry partner, AMPC, the Australian Meat Processor Corporation, which represents red meat processors, and with a little bit of extra cash from AgriFutures.
We basically created this project from the beginning, so we are working quite a lot with the red meat industry for quite a while now, and we defined that there was a need for having a pilot plant using the red meat processing waste to prove to the industry, to give them confidence of what we are doing and how it works.
So today we had the opportunity to look at the two 500-litre reactors sitting in the warehouse, but also to have an in-depth look in the laboratory where the actual lab tests were conducted by Prasad and his team.
So this project is about to improve the biogas productivity from red meat industry. And this has never been done before because most of the time we are working with other waste industries. But red meat industries is actually looking at to decarbonize the industry, and one way is to actually recover the energy from these organic waste that are produced during the processing of meat.
Having that amount of information helps us to quantify where we should focus in terms of producing energy, because in this project we want to move away from waste management concept and into creating value, right? So if we have the knowledge of how much potential each material has, we can select the right materials to have the best outcomes and also the best combination of materials. That's a big part of what we are doing now. When we started the project, we shortlisted 11 red meat processing plants, and we asked them to send us samples from anything that was organic being disposed of on their sites. Each producer sent us more than one sample. Some people sent us like 7 samples, and Prasad's team was very proactive into increasing from 30 BMP tests to 200 BMP tests on what they were doing. Now we have a really good database of so many substrates that are available there that can be very useful for the industry as well in the future.
First, we did the mono-digestion, means that we did not use any other substrate but the material that comes from these sites as such. And then we did the co-digestion next stage, where we started to co-digest the red meat industry waste with the co-substrates like agriculture waste. And we noticed that with some materials, we can go up to 100%, especially with the sugarcane bagasse or grain waste. And the other one is that we also can increase the biogas productions by 50% if you're using other materials like corn silage. But in red meat industry, you have 3 components like lipids, proteins, and carbohydrates. Now the ratio between these 3 is actually the deciding factor whether the process will be working fine or efficient or it will fail. Have a proper ratio between the lipids, proteins, and carbohydrates. And we did 3 different ratios, and we stuck with gold with the one ratio that is 60-20-20.
Well, today the event was a presentation to stakeholders in the project. There were about 40 attendees, and those people came from all across different aspects of the stakeholder chain. So there were processors, there were academics, there were service providers and technology providers. So it was a good mix of different people. Up until now, bioenergy, or biogas in particular, has only really provided 30% of that total thermal energy requirement. So the project was looking, and still is, looking for ways to increase that productivity so there's more bang for buck, so to speak, and there's more bioenergy that can be created on site. There are still a few barriers that we need to address, and some of those are around regulations concerning feedstock types, where you get them from, how you transport them, those sort of things. And also the other co-benefits such as biofertiliser and bio-CO2 that could be beneficial outputs from an integrated wastewater treatment process. So while this project will finish at the end of 2025 and have a business case for members to look at, there's still additional work happening over the next year or 2, addressing all those other factors as well.
So ideally, what we'd like to do is engage with branches of government that are responsible for industrial decarbonisation, bring them on board along with the regulators who cover things like EPA protection licences, and make sure all the relevant parties are in the room together so that the decarbonisation needs of industry can be supported without unnecessary regulation that would prohibit it.
For the first time, we are talking in the same conversation waste management and return on investment, because before it was a pure liability. You simply dispose of your waste, pay for disposal, get rid of it, and now we are creating value out of it. So it's quite exciting.
We'd like to thank our industry partners, AMPC, the Australian Meat Processor Corporation, and AgriFutures for their cash contributions to this project. Without our industry partners, we can't cash match projects, so we're always very, very happy to support our industry partners in their decarbonisation objectives for both them and their industry members.